All right, so
Well,
you just made a piece of scrap, you said?
sure.
Why'd you do that? You had a sample of what to cut. It was right here. And how'd you wind up being smaller?
Well, the last cut was
Like I said,
shorter.
how'd you wind up being lower when you had the sample right in front of you?
Like I just told you, the cut was lower.
Well, didn't you measure it before you hit it?
I did.
Well, obviously not very well, because now you got a piece of scrap.
Well,
3 hours of work later. So how much is you actually really under, because the finish looks like crap. What's the number? There's a mic sitting. There's a mic sitting.
36.
There's a mic sitting right there. What's it say?
That's a caliper.
There's a mic sitting there right next to it.
Oh, this?
Where's the other one? You had all the tools. You had the sample when I left. You've been working all day, so you shouldn't be all waking up. Me, on the other hand, not. So.
Yeah, you're just waking up. I've been up.
You're not at 37, you're at 36.
Yeah.
That means you're a thou under, not a thou over like you're supposed to be.
So.
It means it slips right in that hole nice and loose, doesn't it?
Ooh,
I heard just to go in the hole was that no.
it's in.
The no went right through. See how that works? You hurting yourself again? Oh yeah, well we had a design problem over here too last night. The engineering plan failed to be correct. The problem I ran into was that goes on there like that. The only problem is the small diameter is on the outside, not the inside. So it's impossible to slip it on this way and have a bigger side over here to go over that. So that didn't work. You also didn't deburr your edge for some reason, so it's nice and sharp. So now it has to go like that, and we still got a little bit of an edge there, a little titty. What the hell? How come your finishes are so crappy? See how mine look? What's going on with this?
The 47-year difference.
Yeah. Why are you cutting negative?
Which way is it supposed to cut?
Positive. You're supposed to be on the center, not below the center. Don't you know how to set up tooling?
This isn't my tooling to be setting up.
I told you how to do it. I don't know what the problem was. You were here yesterday. Oh, you're breaking my sting over there. You kicked all my heads out right there. See how that works when you kick the heads? The whole line, the whole line gets screwed up. All right. So how's our length? So you didn't cut the length off yet?
No.
Why not? You cut the end off when you cut the length off. What part did you do anyway? Oh, you cut it too small. That's the only thing you did since I've been here. All right, let's scale that. First thing I do, I told you cut the length, remember? You didn't do that. So, it should be about 1 5/8, our number we had before, but it's not. And this one is over 3/4. You're still an 1/8 inch on the long side. So first thing I do is cut this thing to length. Well, actually, the first thing I do is we're going to fix that. Bouncy, bouncy. You have this nice hole over here. It's on the center. Remember you had that little small little hole? So, put it on the center. See how you got it on center? See the angle of your bit though? When you cut a chip, what's happening right now?
What do you mean?
your angle is negative by about 15 degrees, 10 degrees negative right now.
Okay.
So when you cut the chip, what happens?
What do you mean?
When you cut a chip off, what's
It
happening
cut.
with the chip? You're not cutting the chip, you're rubbing the chip off and you're shoving it right back into the cart you're cutting.
Oh.
Cutting pressure's going that direction right now, the chip's going that way too. So you're now plowing metal off, that's why your finish looks like that. You're not cutting, you're just pushing it out of the way. Because your angle's bad. You never cut at negatives on soft metal. Negatives are for very hard metals, very heavy cutting. Because the chip breaks in front of where it's supposed to be, that's why it goes negative. That's why you look on big industrial bits, where they got big ass holders like that big, they're negative. That's what works when it's negative. But everything else in the world is supposed to be positive, so that don't fit there. So now when you're on center, see how we have positive rake to everything?
Well, you said put the damn big one in there. Leave the big one in there.
I had 10 minutes of sleep when I came in. Obviously, once you put it in there, you would have saw it screwed up. You should have corrected.
How do I correct something I have no experience with?
You work on a lathe. You're a machinist.
Yeah, I have tool holders.
Well, how do you set your tool holder? When things way up here, way down here? What do you do?
Yeah, I just move the whole holder.
What do you do when your bit's made wrong?
I go get a new bit that's made correctly.
And how do you know it's not correct or incorrect if you don't know what you're doing?
So,
I did this over here the other day. See how it's slightly high right now? So that means we have a lot of positive in there.
I'd still guess.
Now you don't have me doing positive really high like that?
I guess.
Now it drags on the back side of the cutter and puts a big rub mark across yours. It gives another crappy finish. Unless you have a lot of clearance ground in your bit.
And you don't.
Well, actually, I do have quite a bit in there, but it's probably enough it would work. But it's not efficient cutting. Now, if you have really, really soft metal like copper or lead, that's what you do. But we don't have that. We have aluminum. A decent grade of aluminum, too. I just like to have it out a little further. When I shoved it out further, it's probably going to back up a little bit. Okay, that's a little bit more closer to being vertical. When you look over here, it should be in the center. Pretty damn close to it. Might be a tick high right now, but we should be pretty close. Looks pretty close to me. So next thing is we got our clearance on the back side over here. So you got minimum clearance back there. So that means it'll want to load up on you a little bit. When you look in this direction, see over this direction, see you got butt loads of clearance over there.
Mm-hmm.
You know why you got butt loads over there?
Mm.
Because you don't have it on this side.
Mm.
So that means you need to turn it a little bit. Go like that. So now you put it in there. You still got some clearance that way. And you got clearance this way now. Now you can determine how much clearance you want. We can be half that, be alright, but you can't be a third of what that was like we have it. Now the problem with this way is, if you want to cut backwards, so you got very low clearance to dig into it.
Mm-hmm.
So that's why you go in between the numbers. So these I just kind of eyeball the angle right here that I want to run. That's what I use. So now, when you're in here like that, so we have a decent amount of clearance here. So that's not going to chip load too much. At least you really got some crappy material. Yet on this side, you can see how we can plunge in a little deeper without having a problem. So we can do a big cut in reverse if we want to, which I do at times. Now right now we're a little on the fat side. So what I do is I cut a little bit off. Get an idea about how much I cut off by looking at it.
Mm-hmm.
And that's about where we want to be at. And that's rough and then like this. Got the chip loads up in there because I don't have no clearance. That's why you have clearance. Okay, that was a rough ass cut. Notice how my finish is smoother. But actually it's about the same material is. Were you cutting about that speed?
Mm-hmm.
Why would you do that on a finish?
Cause I just cut the face off of it.
See it bounce, 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 bounce. You didn't check up very sure.
I cut till I got the big hole, and then that was it.
Didn't measure. High spot on the outside there. You can feed it quick, like this. See the fogs out in there. So now it's a lot smoother than it was. But it didn't quite clean the inside, but for now we're going to rough it in. So now you go over and measure it, see where you're at. See, a little bit over 5/8 right now, so it's still heavy. So we're going to do this again. Go over there, make the chamfer. See how much you want to cut off. This time we're facing off instead of turning it off. Turning it going that way, facing goes this way. Stop like that, it fucks up the finish. Okay, now you go back in here, measure it again. See, we're still over 5/8.
Mm-hmm.
Didn't cut enough. Now, what was the number we're looking for over here? It's less than 5/8. And their collar a little over. 5/8. It's under 5/8 on the taper. Okay, so now I'm going to take a nice quick cut again. Grouse chattering.
Mm-hmm.
Good combination. Okay, should get close to 5/8 now. See how close to 5/8 we are?
Mm-hmm.
Really right on the end of it over there correctly. We are at 5/8. Maybe a little under, not much. Still got a little deburr, but not very much of a deburr edge or chamfer. Pretty shallow. Okay, now this is going to be our finished side out here. So we want to bang ourselves in the way. We're working on this tool. Go ahead and make this a little bigger. I like the radiuses, so we took my thaw. Over long sleeves on the blades are a bad idea.
Mm-hmm.
Especially when you're running right against it.
Mm-hmm.
That's why I turn my truck down nice and smooth. So you go like that one nice. I made sure it was deburred.
That's unsafe.
No, it wasn't because it was deburred.
That's unsafe.
Now, if these are sticking up, yeah, it hurts when it hits your fender.
Yeah.
I've had that before.
Still unsafe.
Or if you jam into here at high speed, that hurts too. I've done that too. These are not very deburred.
Spinning things, no.
Well, it's not very fast. Just a few hundred.
And stay far away from spinning things.
Oh, is that how that? Is that the plan?
Mm-hmm.
Oh well. I can't read. Missed the plan. All right, deburred. Fit now? Fits that far.
Yeah.
Fits that far. I had to deburr your shaft with a big nick over here.
I bet.
It was screwing up the surface in here. Okay, it goes on. It doesn't go over here, see? It's going to go over that.
Yeah. You gotta make the hole bigger.
A lot bigger. We gotta work on this too, though. So, I gotta cut this down. This is not concentric to this surface because it'll go like this. And did you see that when I was deburring the edge?
Mm-hmm.
When you put it in the lathe, you just clamp down on it. You probably didn't rotate it and find a sweet spot. Where it's, see, that's how you're supposed to do it. You gotta find the sweet spot where. See, it's right in the middle like that. Cuts truer like that. And it doesn't wobble so bad. You can't just slam it in there and call it that.
I don't know. We have collets at work.
You saying call it that?
Yeah, I have a collet lathe at work.
Okay, so we needed 1 inch of straight. 1 inch of straight's an 1/8 inch from the end of the chuck, which is where I work at. True still. I don't know how bad it really is. Go over here and look at it and see what it's not too bad. Okay, now this here is off. You know why?
Didn't you say you cut it?
Because somebody else screwed up too.
You cut it too low?
You know. What length do we need?
I don't know.
1 inch from this edge. Actually, we more than an inch. We're on this surface. And this is our inner side. So we need just under an inch and a quarter. So it's 225. It's probably that number you had earlier. Here's your cheat sheet.
Right there.
222. So yeah, there it is. 222.
1, 2, 2.
2.
Because it was, you said 1 1/4, right?
1222 is what I measured. It could be 1.220 also. It's 2 thou less. I can sacrifice 2 thou and I don't really care. Okay, so we gotta make sure we have that dimension from this backside to here. Now the problem I just did, I put that big chamfer on there, and the problem is the tooth would be real thin over there, so we'll probably just put that all off.
Mm-hmm.
Oh well. So what I do, so I don't screw up too much, I go over here and figure out my length of that. 1.2. So you can read it better. So I'm good right there. So that's why I had clearance on the backside. I was able to do that. So.
Mm-hmm.
Now you go over and measure this, and you make sure it's long. Are we over 2.2?
Mm-hmm.
What are we at?
3.
3 point, probably 4.
5.
Probably 3.4. Like that. .25, 245. Okay, now I need to make sure I'm in my length. I want to do that. Okay, let me think about this before I screw this up again. I think I just did. I think I screwed up again. This is what we're turning this down to slip into that hole. I don't know, I'm doing right. The back side, this is going to be turned.
Yeah,
It goes this direction.
Mm-hmm.
Okay, so that's going to be our inside. This is our outside, so I'm good. I didn't screw it up yet. I'm working on that, though. Still might. Okay, I don't like cutting that direct. I like cutting this direction. Now, so you don't go too small, is make sure you don't go less than what this is. See how we're still clearanced it?
Mm-hmm.
See we're just under 3?
Mm-hmm.
If we go to 3, do we hit? No. So don't go under 3. The problem is you didn't reset this after you started boring. So now we're turning, we gotta go the other direction and play. We forgot about that, didn't you?
Mm-hmm.
Okay, now we're at 4. Past 5. So we're good to at least past 5, because see we're not hitting. So if we go to 5, we're good to 5. We only got a few more thou before we hit. Now if you take that all at one cut, it will plunge in deeper and cut too deep. So don't cut too much. I'm not sure how much pressure this will cut. I can't feed it at this much cut, but I can do it by hand.
Yeah, because you just cut like 100 thou off.
Yeah, off both sides, yeah. Now, there's no lubricant right now, so that's why it's kind of loading up.
You mean this lubricant right here?
Yeah, that stuff right there. But we don't have any of that, so we're going to be careful about the loading. There you go. So you don't have to have lubricant. Sometimes it helps, but you don't have to have it. These are the ways these are. Okay. See how that's more better?
Mm-hmm.
You know what's our feed rate? That one.
Mm-hmm.
Okay, what's our number we're using?
Under 5.
No, we were cut 5. Alright, so there's our rough finish, kind of rough. Okay, what's our diameter we want?
Whatever that one is.
More than this. This
You
one,
should be at
this one's too small.
157.3.
38. 57.3, what we at?
I don't know.
You don't know?
150.
It's 575 at least.
8.
You got
I don't know. I can't see that close.
8.5. Put back here.
No, I can't see that the line's that close.
Put
2,
those up
3.
here. Put
Yeah,
up-
you're oversized.
Can you be over there? You can be
You're
over there.
10 thou over.
10th out. I'm gonna turn high. That's 10th out.
Yeah, sure.
I don't think so.
Well, your shit's also low, so
I'm low.
yeah, you're low, so
You go 5, 10, 15, 20, 25, 30, 35 almost.
oh, so you're 35 thou
You were
low.
full turn off, it's 25 to turn. So you know what that means? It means we can cut 10 more thou. At least. At least 10 more thou. Probably shouldn't do that. We'll go slow because plus I gotta get the sheet off the end of the bit, so that's better. That's the buildup on it. Somebody's roughing it. Not loose. I knew that was. Remember this gonna be now?
10 thou lower.
10 thou lower. That's a good call. The finish is getting a lot better now.
Taking less cuts.
No, I got the buildup off the damn bit. Okay, what number we got now? What number do we want?
157.3.
We want to press fit.
So you want 157.4?
4. 7.4. So we're at 18 and 5/8 over that, 7/10. That's good, but 18 and 7/10 off. To get
It's
to 7.5.
aluminum,
To
so
get to 7.5.
technically we could press it in right now.
To get to, no, you can't.
Why?
You won't go in.
It should shape it, right?
You're not going in that kind of press fit. You're not damn way. There's no way you put that thing back here without that. So we'll never do it. It will shear the metal right off. You can go length enough tonnage on it and it will shear all the metal off. It's really good.
Right on the money.
Right on the money? No, we're at 6 something over. And then we'll be 1 under that. So how much more we got?
I don't know. I didn't get a very accurate reading off of that.
7. Check 5, I think. Sneaking up on our numbers. That way you don't overcut. We have a go, no go, because if you're cutting on that, you're too small already. So that's how I know it's not too small yet. Okay, now, what do you got now?
Was that 73?
0. That's 76. You got 5. Then you got one more, 6. And we want to be what?
73. 573.
Where'd you say that?
It's right here.
That's the size of the hole. The one press fit, remember?
Yeah, so it should be 75 or 74.
74. 1 thou press. We're at 76. So how much more do we need to take off?
1 thou.
1 thou. Just to go it over here.
Halfway.
We'll have to take off 2 thou. Got with the cutting there. The gear's coming over there. That don't look like 2,000.
Might be.
I don't think so. Over there looks like 2,000. One back over there. So right now we're at 60, a tick over 64. Now what do we got? See, it's still big.
You cut a thou off?
I got less than a thou. Got 1 thou there.
At 5/10 there.
So we'll move about a quarter over, but it moves a little bit. You're supposed to check. You're supposed to read this when it's on there, not after you pull it off. So we're 1/4 thou up, or yeah, about 2/10 up there. I got 2/10 taper in there for some reason. Okay, we still got a thou to cut. Looks like the last cut is that much bigger. So we didn't cut over here, so we know it's bigger than over there.
Right.
There's 1 thou under. Quit cutting over here for some reason. Not enough chip roll to make a cut. That's the problem with cut real low. If you have really, really sharp bits, it will do it. If the bits get duller, it doesn't want to do that. It takes a certain amount of chip roll to do a cut. So we're going to cut 1/2 thou. Well, 3/4 thou. 2/10 over. Down here, still 1/2 thou up. 74.5. So that's a thou and a half press right there.
Mm-hmm.
Now, considering that everything else is so loose, and that's the only press fit we have, I think I'll leave that in there.
Mm-hmm.
Okay, now how's our diameter, our length? So our length right now, I'll measure it this way. We are just under 3/8. Will put us right there. And in this other direction, we should be a 1.22, not bigger. We are just under 3 right now. 275 right now. The problem is, I think some of that's going to go off when we bore the hole out because it's so thin.
Mm-hmm.
The big chamfer's going to cut me off about 30 on that other end at least. So I'm going to lose that 30. And a little bit more here. Edge is broken. Looking good. All right. So now,
It's hot. So
it's not hot. It's cold in here.
the metal's hot though.
The metal's hot. Doesn't matter. I already measured. I know it's undersize. When you only got a thou clearance, you got to get just right or it won't go in. See, that's where our press fit starts right there.
Mm-hmm.
The rest of that's press fit. So we go near that deep. Could go a long ways. Make sure it goes this direction here is what we're supposed to be doing. What am I doing here?
Shoving it in just like that.
Supposed to go in this direction.
Right.
Mm-hmm. Yeah, it looks like it's too far out, but I know it's not. That much damage. Only got that much press fit. It's just about flush from there, about an inch hanging out there, less than an inch hanging out that end. Damn. Okay, this side here is obviously too small. Alright, so now I'm going to go ahead and turn this down, bore out this hole to go over this big shaft. And we got that step right there, we're going to go over that too. Because I'm going to go completely in there. You got that dimension figured out?
Whatever size that hole is, that hole should be.
Whatever size that hole is, that's a good number. Okay. Alright, take a break. Me and Mike.